Okay, thank you so much. Welcome to today's lesson. I promise you the last time I taught you that today I'm going to teach you about valencies. It's necessary for you to know about valencies. Why? Because if you don't know valencies, you cannot be actually to balance your chemical equation very well. You cannot be able to write chemical equations very well. So anybody that must balance a chemical equation and write a good chemical formula of a compound must actually know very well. We have a good knowledge about what is valency. What is valency? Valency is simply the combining power of an element. The combining power of an element. The power that one element wants to combine, that's the combining power it uses to combine. So I want to ask you a question. If I ask you to write water, which is H2O in this thing, how do you now ask yourself this? H2O. I know some people have been asking that question. How come H2O? What they simply did was exchange of their valencies. In the last lesson, I talked to you about oxidation numbers. I talked about the metals having plus and the non-metals having minus, and I told you about some exceptions to that. So that's going to play an important role. If you didn't watch that video, can you just go back and watch the video? But they're going to play a very important role for you to understand something about what valency. As I've said, is the combining power of an element. Any element, whenever they want to combine with each other, they interchange their valencies. They interchange their valencies. So in any chemical combination, is simply the interchange of what? Valency. Remember what I told you about oxygen, the valency. I told you about hydrogen in the last lesson. So here I'm going to use it as an example to teach you what we call valency. Here, the difference between valency and oxidation number is that valency doesn't have minus or plus. Every valency is just plus. It doesn't have minus. Like oxidation number, we will have plus and minus and this. No, but valency is always what? Plus. Please note that there is nothing like minus in valency. There is nothing like plus. It's always what? Plus. That is the only difference between valency and what? And oxidation number. So let's go. I told you before that the oxidation number of hydrogen is equal to what? 1, and that of oxygen is equal to what? -2. But here it doesn't play a role because I've told you that in valence we don't consider minus or what or plus. So this becomes 2 and 1 as their valency. So whenever they want to combine, this want to combine with this, hydrogen want to combine with oxygen in order to form water, what they will simply do is to exchange their what? Valency. So how do they exchange their valency? You look at this, hydrogen has what? 1. Hydrogen has 1 as its valency. Oxygen has 2 as its valency. So whenever they want to combine, they will what? Exchange. That means this will collect this person's own and this one will collect this person's own, making them to be written like this: H2O, which is water. Which is what? Water. Are you seeing how it works? This is how we get the what? The valency. What the valency does about? Yes, they are combining power that they what? Exchange. Okay, let me also go to this a little bit. Okay, you have seen something of this nature, H2SO4. And you have seen this. This is called what? Tetraoxo sulfate what? 6 what? Acid. So how do you come about that? How do you write this? Some people are asking the question, how do you write this? How do you write this? It's simply the combination of their what? Valency, the exchange of their valencies. The first I told you about that hydrogen has a valency of 1, while this has the valency of what? 2. So without not even looking at it, if you want to know the valency of any element, just look at the element it combines with and look at what did you combine with. If it is to know that the valency of this is 2, if this becomes 1, know that the valency of this becomes what? 1. It's just as simple as that. You get what I'm trying to say? So this shows that the valency of hydrogen here is equal to what? 1, while the valency of this is equal to what? 2. So whenever they want to combine, they will exchange. Hydrogen will give its own to this, while this will actually give this to this, making to them to become what? H2SO4. Are you getting what I'm trying to say? Okay, let's watch another one. Let's do for this. What of when calcium wants to combine with what? Oxygen. When calcium wants to combine with oxygen, what do? They exchange their valency. What's the valency of this and what's the valency of that? I don't mind if you can just try it out. Can just try it out. Okay, give me a few minutes. Let me just try it out for you. Remember that when I told you this, the valency of this will give you what? 2. This is also what? 2. So when they combine, they will form 2 by 2. You divide them, they will give you what? Ca. We call this calcium oxide. Calcium. Somebody asked me why not like this? 2O2. Why not like that? Let me write it here so you can see C2O2. Why is not like that is that this will divide this, making them to become what? CaO2. So this becomes calcium what? Oxide. Calcium what? Oxide. So you see, it's very easy. Just whenever you want to combine any element, know their valency and exchange their valency. Simply, you write a very good balanced what? Equation. Okay, let's watch this again. Let's watch this again. Okay, I'm going to just deviate a little bit. Let me say sodium combining with oxygen. I know sodium is group 1. Don't worry, I'll find out to teach you about how to actually do the periodic table. Sodium is what? Group 1, and this is what? This is actually 2. This is 1 and this is 2. So what do they do? They will exchange. Since sodium has valency of 1 and oxygen is equal to what? 2. They will exchange, remember? So it becomes this 2O. Remember, this is sodium what? Oxide. Sodium what? Oxide. So it's sodium oxide, you know, but the combination, people think that these two, no, these two is simply what? Exchange of their what? Of their valency. Exchange of their valency. Don't forget, it's always whenever they exchange their valency that they combine together. Okay, have you seen this before? Have you seen this before? This is trioxo nitrate 5 what? Acid. You know, remember, for you to see this, you know that this is one. The valency of this is 1, and this is what? This is actually what? 1. So actually, this is how we can be able to work on valencies. So I want to encourage you to try this out for other formulas. Maybe look at other chemical compounds and see how they are exchanging their valency. And I promise you, you'll never get lost. If you have any question, you can type it in the comment section, and we'll be ready to answer your question. Thank you so much. Bye.